Well, welcome back everyone for the absolute final video in this series. And it would have been done before, but I had another request for some, from a couple of folks that wanted me to kind of go over multimeters a little bit. Nothing super duper in depth, which is what I'm glad to do. I have no problem with that. We'll cover a little bit of AC, a little bit of DC voltage readings, and we'll do a little bit of resistance. We may check out a couple of resistors and maybe a capacitor or whatever. Anyway, before we do that though, I wanted to back up a little bit on this signal tracer from the last video. You recall I said that it was really dirty and everything, and I went ahead and cleaned it since then. And I wanted you to hear the difference between a good, really good tube operated vintage signal tracer versus that little solid state Micronta. And you'll hear that this thing, now that I got everything clean, it's tube operated. Keep in mind, it's got a hum, right? Hear it? That's normal. The reason it's normal is because the probe is picking up lots of stuff around us, like buzz from the lights and all that, and especially in here, because we have fluorescent lights. It's trying to pick up all kinds of things. After all, this is basically, this is an antenna. You're picking up whatever you pick up here will be amplified by the tracer, which is an amplifier, is all it is. Let's crank it up a little bit, and if you touch it with your finger, see how loud it gets? Again, that's normal. And what I'm going to do, I got the ground wire on this probe hooked up to a gator wire. What I'm going to do is go ahead and hook it to the ground on this radio, which is I can use the negative side of the electrolytic capacitors. If you have a system, have a radio that's grounded to the chassis, you would of course hook this to the chassis. Let's go ahead. I'm going to turn up the radio volume a little bit. Now pretend the radio volume is not there. We're supposed to be troubleshooting a radio that has no sound, okay? But it's the only way I can show you without taking it all apart again. I don't want to do that. Just to show you this. Now, let's turn the volume down on this because it's going to be a lot louder. Here we go.
Yes, John Cranley, the Mayor John Cranley referred the legislation to my... I took it up. I ultimately...
We can even go lower yet.
Compromise, and ultimately there was. And this is good. I think it's an example that...
Okay, that's what she sounds like when you have a larger signal tracer. In particular, Heathkit IT12. I like them. And they're a little bit bulky, a little bit large, but hey, that's what it's all about in my mind. Okay. All right, let's move on to the multimeters now. Let's take a look at the 5 meters that I have. I have a Heathkit VTVM model IM11. Now this is VTM, means vacuum tube voltmeter. And that's exactly what it implies. Inside this critter are some vacuum tubes, I think there's 2 of them. Not sure, it might be 1, I can't remember. It's got some tubes in there. It does not have transistors. I use this, I bought it and I use it for doing alignments, because it has a nice big scale and it conforms more readily with the expected voltages as laid out on the schematic or the service manual. And I like it because it reads, zoom in here a little bit, I can get your AC. I can switch from negative DC to positive DC when I'm checking certain voltages, and it has ohms, and then of course you have your different scales. Now the ohms or resistance is laid out, R times 1, and then it goes 10, R times 10, 100, on around. You have an ohms adjust, which would be to the extreme right here when you touch the probes together, the 2 probes, the negative and the positive, which is on 1 probe. Actually, this kind of takes a special probe from all the rest. I didn't bring it today because I didn't want to put that probe in with all these other meters and everything and have it take a chance on it getting damaged. I'll probably bring it in tomorrow and we'll cover it then separately. Those probes are kind of hard to find. It plugs in right here. It has a jack just like a speaker plug, and it just goes right in there, and I'll show you that tomorrow. And that's basically all I use this for. It's got a nice big face. I like that. There's different kinds of vacuum tube voltmeters. I happen to like another one. It's called the RCA Volt Ohmist. Now the Volt Ohmist is this one right here. Zoom in on there. Boy, that's a big sucker. That's a big screen. This is the senior volt ohmist. They have a they put out, back in the day, they put out junior volt ohmists also. I think our good buddy Lockmeister, he bought one of these. He has one of these. And I'll tell you what, they are nice. They're big. You don't have to get on top of them to read the scales. The other multimeters I have is one from Centec. It's called a P37772. It's sold by Harbor Freight. I wanted this one because it has a nifty thing that I like. You know, I don't have to keep standing up to look at the thing, and I don't have to go like this to read it. And this has a thing, you just pop it up with your finger. I like that, see? Jacks it up at an angle, and when you're done, you just push it back down. That is cool. I wish a lot of multimeters had that. That is cool. And it lights up. It has an on-off switch up here, which I don't like because we're all the time hitting it. The switch should be a little bit down here on the side somewhere where we don't hit it all the time. Every time I hit this thing, it turns it on. It drains the battery down. But I can adjust this all the way up where the light doesn't reflect on it. And when I press the button, we get a nice big display. That I like. Its accuracy, oh, I don't know. You know, it's as accurate as any other cheap meter you buy. I think I only paid 20 bucks for this thing, maybe less. I can't remember. It wasn't very much. And, you know, I get a reading. If I want to hold it there, all I got to do is press the hold button over here, and that'll hold that reading until I hit it again. And once I hit it again, it'll go away. And, you know, it has your standard scales. We'll go over a scale on one or two of these, and they're all pretty much the same. Also, one other thing I liked about this, it came with a wire and a connector that plugs right here into that green thing down there where my thumb is, and it reads the temperature. And I've only used it like once or twice. I used it to read the temperature of the power transformers in my radios that felt, you know, like they were hot. And if I remember, yeah, it reads in centigrade only. It does not read in Fahrenheit. So you have to go on the computer and translate it over, or transfer it over, or figure it out yourself on a piece of paper, which I'm not going to do at my age. I just go to the computer and let it do it for me. Anyway, when you're done, just go ahead and shut her off, and she's good to go until the next time. Comes with a set of probes, Harbor Freight, real cheap. And if you break one, you drop it. Anyway, this case right here, pardon me. This is a helps it, keeps it from breaking. This yellow multimeter was the first one I had when I started working on these old radios. I went in where I work one day. I was talking to some of the maintenance guys in there, and I say, "You guys have any old multimeters laying around that might be partially working that you're not going to ever use again, and I can maybe buy them? You know, I'll pay the company a couple dollars for it, or whatever you want to do." Because usually in the maintenance department, these things are everywhere, and you know they're usually broken, they're chipped out in the bottom, or people have dropped them, they're covered with grease and all that. And I figured there might be one in there I could use, you know, just to get started. Well, one of the maintenance guys says, "Well, you're in luck. We had a guy come in here the other day from the IMS company, or a guy that carried these things in his company, and he gave us a couple of these meters for free." He said, just, you know, as a token of goodwill or good wishes or whatever. He said, "We have no need for them." One of them, another guy took, but he said, "You know, this one will probably sit in our office forever. You want it? It's yours." I said, "Well," I couldn't believe it. What timing, huh? So anyway, I went ahead and took it home, and I used it for years and years. And that was before I got this one right here. This has been an excellent meter. The display is not as large as the big red one. It's pretty small, but it has done the job. Works great. Let's go to the next one. This is a meter wifey came home with one day from Radio Shack. She went down to Radio Shack and bought it for me. And you know, this is called an analog meter. Incidentally, these two here are digital meters for those that don't know. They're digital. Why? Because they put out, when they display in digits, okay? You betcha. I think that's liquid quartz in there. They may have some new kind of crap in there. I don't know what it is. Probably still liquid quartz. Anyway, this is an analog meter. It's got a needle. See how the needle moves? Analog. Yes, analog. Years ago, they used what they called down here. They had a jewel down in here. I'm sure this one doesn't have it. It might. I don't know. I know the old Simpson meters did, the 260s and so forth. They had a jewel down there that needle would pivot on. Pretty nifty. It was called D'Arsenval, I guess was the name of the guy that invented the needle movement. Anyway, it had a D'Arsenval meter movement. I knew that. Anyway, that's your analog meters. Okay, I like these when I'm doing continuity checks because, you know, if I touch my probe on one side of a coil and the other side of a coil and the needle jumps over real quick like, then I know I've got continuity. Okay, I don't have to sit there and watch a digital thing to count down to tell me if it's got 0, you know, showing continuity or not. This baby here just whips right over there, telling me that in fact the coil is good. One other thing about these analog meters and using them for continuity, you can take, if you have several coils in a row and you know where all the contacts are, you can stick this on the ground side of the coil like so, and then just take your red lead, just leave this in place on the ground side either with a gator wire or whatever, then just take your red lead and go just touch it down each coil, and as you go from coil to coil to coil to coil, you don't have to wait for the digital meter to settle down. This baby here will just go whoom, and you touch whoom, touch whoom. It makes it real fast. Bap 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 bap. You can actually, that needle will jump up showing you have continuity. Now let's look at our last meter, a Fluke 73. This is kind of an interesting meter here, and the reason it's interesting to me is that it was given to me by Brendan, my electronics mentor up in Michigan. That guy's done so many things for me, things you don't even know about, things that you will soon know about, all kinds of stuff. Anyway, he sent me his old Fluke 73 meter. He bought himself a new one, and he said, you know, the way he put it, he says, it just breaks my heart to see you using these meters to repair your radios. Let me send you something that's good. Anyway, he sent me this. He says got a couple cracks and chips on it, but he said he compared it to the Fluke he got, the new one, and he said it's just as accurate as the day he first bought it. The only problem with it that I have as far as videotaping, when I'm doing videotaping, is sometimes it's been around a while. The digital display is not quite as bright and clear as it is over here, say on this one here. See, this one lights up big. It makes it easier for the people viewing the video to see. This one here is more accurate. Now this meter is what you call an auto ranging meter. Auto ranging, what do you mean by that? Well, if you want to measure a certain, on these meters here, if you want to measure a certain range, you have to go around and set your switch like that to the range. For instance, if I wanted to measure, let's take AC voltage of 100 volts, I would set the meter to 200. Okay, and if I wanted to go higher, I'd have to set it up to 700. Well, you don't have to do that with this. This is an auto ranger. All I have to do is set the button to AC volts, period. And every reading I take, the meter will automatically read it. I don't have to switch ranges or anything. Same thing for DC volts. Okay, same thing down here for, this is millivolts if I'm really down low, and the same thing down here for resistance. I just set it once to resistance, make my checks, and this thing automatically reads it. No matter what the range is, it'll tell me. No matter what the value is, it'll automatically tell me, without having to sit here and switch ranges all the time with a switch in the middle. Okay. It also reads diodes. It has a beeper on there for a diode. If the diode's good, it'll beep. And then I have AC amps I can read with it down here, and DC amps I can read with it down there. Which, of course, once I get into the 10 amp range, I have to go ahead and change or once I get into the amperage range, I have to change the wire from here to there. Okay, same thing with all these. Actually, if I want to read milliamps, I have to change the red lead over to here, and 20 amp max there. And this one here doesn't quite do that. Let me see, what does this one read? I haven't used it that much. This doesn't. Yeah, this just reads some small microamps. That's all, and milliamps. And this one here, I would also have to change the leads over to read 10 amps or milliamps, and that'll give me a different display on the screen. So those are, several different kinds. I like the auto ranging. Radio Shack, by the way, sells a very good auto ranger that reads very well too. I don't know the number of it, but you could check with them. You might want to do it quickly, considering the financial condition of Radio Shack. Okay, next thing we'll do, I'll grab a handful or a couple of resistors and a couple of capacitors, and we'll go ahead and take a couple of readings from this thing, maybe a few voltage readings using our old radio that we've been working on. See what happens. From some of the private messages I've received and emails, I have to assume that there are several out there who have no idea how to set up a multimeter and how to use it. So that's the assumption I'm going to go on. I know a lot, most of you, if not just about 99.9% of you, know how to do this. But when you do a YouTube video or give any kind of instructional kind of thing to anyone in a collective group, you have to keep it at the level of the lowest knowledgeable learner. You can't talk to the guys that know all the stuff. They shouldn't be there anyway. Anyway, this is a multimeter or molt. I'm just gonna assume you've never seen one in your life. That'll always cover all the bases. This is a multimeter, or otherwise called multimeter. Okay, and it is digital, as I said. I happen to like this one a lot. It's cheap. If I drop it and break it, who cares? I just throw it away and get another one. But it has a lot of functions on it, a lot of neat functions. Let's take a look at some of these here now. The meter is broken down into different areas designated by these lines. Now, not all multimeters are going to have lines like this, but just many do, okay? Right here, from this line right here over to this line right here, everything inside there, that's resistance. See that little ohm sign? That's resistance. Over here is DC voltage. Here, these are the scales for DC voltage. These are the scales for resistance. Okay, this is 200, 2,000, 20,000, 200,000, 2 million, and 20 million ohms. Those are ranges. Those are ranges. Over on your DC voltage, you've got the same thing. You've got ranges. You've got 200 millivolts. You've got 2 volts, 20 volts, 200, up to 1,000. Okay, you shouldn't need more than 1,000 volts, unless you're a highly skilled technician who does exacting particular kind of work. Most of you need to stay away from 1,000 voltages. If you don't know how to use a multimeter, stay down in the 200 and below range, okay? Until you do learn what you're doing. Down below it, in this little box right here, is the AC voltage. And again, it's 220, 200, and 700 volts. Again, be careful around that 700 volts. Even the 200 is pretty high. Just be careful, dealing with voltage. Once you start using a multimeter, you are going to be dealing with high voltages. Unless you're in the resistance scale, of course. You never want to take a resistance reading with power applied. Got that? Do not take resistance readings with power applied. Unplug the radio, unplug the TV, unplug whatever it is you're working on if you plan to take resistance readings. Do not take resistance readings with power applied. I'll say it one more time. You'll blow the meter. You'll smoke it. You will smoke it. All right, the next little thing we did. Now this I like on this particular multimeter. It came with a long wire with a dual plug on the end that just plugs into here, measures in centigrade, and I can touch it to the power transformer and get a reading in centigrade on my screen. Now I haven't used it since my grandson, our youngest grandson, bought me that digital laser temperature thing where you just point the light at it and it gives you a reading. That works a lot faster. You can go like bing 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 through a radio and test a lot of things. You don't have to keep moving the wire. But this meter does have that capability. Kind of neat, I thought. Now down here, this row of stuff is for checking transistors. You just plug a transistor in, the emitter-based collector. Then you got your emitter-based collector. You just plug in your transistor there, and it'll give you a test. Over here we have amperage. This is DC amperage, and this is AC amperage. Okay, a little AC sign there, a little DC sign there, and this thing right here is CX. I have no idea what this is for. Don't care. Never used it. Probably never will. Time to move on. Over here we've got this F stands for farads. For measuring, you can measure the value of capacitors. This would be a 2 nanofarads, 20, 200, 2 microfarads, 20 microfarads, okay? And over here you've got hertz for 20,000 hertz. I've never used that also. I have no idea what it's for. Well, it's obviously for measuring frequency. But that's about all you need to really know. That the things you're going to use the most will be resistance, DC voltage, AC voltage, maybe some temperature. If you were to own this meter, you'd maybe check temperature once in a while. And if you work on a lot of, transistor portable type radios, transistor radios from the 50s and 60s, and, yeah, you might check out this. I have an actual transistor tester for that. Amperage, yeah, you might want to, if you're not familiar with how to use a multimeter, stay away from the current positions on these things until you learn, So now I would say from hertz through the farads, I always just replace capacitors. I'm not going to sit here and measure a bunch of capacitors. When I get old wax capacitors, that's it. They're out of there, new ones go in, end of story. In the can they go, no good. Saves time, trouble, and energy. I'm not going to keep a wax capacitor in a radio that I'm restoring. I don't see any sense in doing that, So it's just a problem waiting to happen. And they're so cheap, to replace. My God, you can replace them with one of these things right here in a heartbeat. I've never had any trouble with these yellow caps, by the way, never. Anyway, down here, for some of these readings up here, you have to reposition your leads, okay? If you're going to measure milliamps or over here, up to 20 amps, you'd have to move your red lead over to either one of these. But there again, like I said, stay away from the current side of the house for now, for the beginner, okay? There's plenty of other videos out there that will help you on how to read current. It requires the meter to be in series with what you're reading in order to get a reading up here on the current draw. That's all you need to know. Now, by the way, this thing here, if I'm looking for a reading, I can always hit a hold button. I can press that button in and it'll hold that right there and keep it on there until I release it. It's kind of a neat feature. And that's about it. That's all there is to this meter. Very simple. Now this is going to be a long video. Hope you don't mind. Now we'll take a few readings. I think we'll take a few readings of these capacitors. We'll take a few readings of these resistors. And then we'll go into our, our radio that we've been using in this entire series. We'll take a few resistance readings in there, okay? Maybe a voltage reading or two. By the way, I left this in that position for a reason and then turned right around and skipped over it. I can't believe it. This is a little diode symbol with like a little volume thing next to it. You'll see this on a lot of digital multimeters nowadays. What that does, if I'm sitting here testing a whole bunch of wires to see if they have continuity in them, and I could hook like this at one end, and then I could take my probe and I could go beep, down each wire to make sure I've got continuity between that wire and the ground. And what this does is it gives me an audible signal, which means I don't have to keep looking at the screen all the time to see if I have continuity. Let me give you an example now. We'll say that the lead on this capacitor is a wire, and it's one of, say, 25. If I just wanted, I don't even have to look at the meter. All I have to do is listen. Now, listen now. See it? I don't have to look, and if I go, I can go to the next wire. And if I get a beep, next wire, get a beep, next wire, get a beep. Saves a lot of time and trouble, folks. Trust me on that.